The world economy is currently jittery owing to a spate of economic tariffs that have been unleashed by one particular notorious individual. But one thing that is sure, that is definitely going to send chills down the spine of even Donald Trump is Mother Nature. And one such catastrophe that Mother Nature unleashes in its form of her fury is earthquakes. So recently, a lot has been reported about one of a massive earthquake in the past 100 years, which occurred in the Far East, that is particularly Russia. So we are going to discuss a lot of interesting aspects, not just the theory, and I'm going to explain each and every aspect so every person, even a layman, can understand. So just stay tuned. So, first of all, we will locate on the map where exactly we are going to travel to and the earthquake took place. So, this is Russia. This is where the earthquake took place. The volcanic eruption subsequently took place. So, this is the Kamchatka Peninsula. So first of all, you can see if you if you carefully see the picture, I hope it is visible on the screen. You can see this a little this portion which is lighter shade of blue as compared to the rest of the part. So you can see here, you can see here. Okay, so these parts. So this is very interesting concept of plate boundaries and subsequent trenches. So we are going to discuss that. But first of all, let us travel to a destination where the earthquake has taken place and subsequent volcanic eruption. So, actually, the earthquake took place in this region at a particular plate boundary. Don't worry, these a lot of these terms might seem alien to you, but I'm going to explain. So, this is actually, if you can see the boundary. So, Russia, just like a country, India is divided into various states. Russia is divided into several federal districts or federal subjects. So, one is Krai, commonly known as the 1250 kilometer long Kamchatka Peninsula. This is its administrative headquarters, Petropavlovsk, Kamchatsky. And let us locate the earthquake. So, initially, the earthquake, which erupted after almost a century, is Klechevskoy. So, names are can be difficult to pronounce sometimes. So, this Klechevskoy Skopka. Okay, and recently, as of yesterday, one more volcano erupted in this Kamchatka Peninsula. This actually it is written in Russian, but its actual name in English is Kreshnenikov. Okay, so this is again Kamchatka Peninsula, and so we are going to focus on this region. So this is an illustration of the Klechevskoy volcano which erupted in the Kamchatka Peninsula. So some important terms before we go on, before we pursue the main concept. First of all, you should know what exactly is lithosphere. Very simple concept if you go by the exact definition. Basically, I'll write just the keywords. It is a rigid, solid structure primarily composed of the oceanic and continental crust and uppermost mantle. Now, you might have studied this in geography in the sixth or seventh standard. I'll just provide a refreshing lesson for you. You just need to remember some basic, the uppermost layers. So, let us assume that this is the ocean and this is the mountain. Okay. So, in simple words, We first have this forms the part of the crust. Okay. Then this this plus this uppermost part of mantle. Okay. So this is the crust. This is the continental crust. It lies beneath the continent. This is the oceanic crust. So they differ in rock composition and densities, etc. And this portion is the uppermost part of the mantle. Below the crust, we have the mantle. The uppermost part of the mantle is the together they constitute what is known as the lithosphere. So these are the solid structures in nature. You just need to concentrate this much till on this much till now. Now this corresponds to plate. So lithosphere, the entire Earth is not what it seems. On ground, the continents and the oceans, it might seem that okay, they are arranged in a particular form, but beneath those oceans and continents, the entire lithosphere is broken into large, amorphous, solid, rigid plates, which are known as lithospheric plates, or we can say the tectonic plates. Fine. So, what happens is due to convection currents, just remember there is liquid here, semi-solid asthenosphere here. So these currents are forcing the lithosphere to move because they are broken into several parts. So one lithosphere plate is this. So sometimes they might go diverge away from each other, or sometimes they may converge. So they are continuously in motion. We cannot feel them moving beneath our feet. Now, what happens is sometimes they stick to each other. When, for example, they are converging, so what happens is obviously they are not as smooth, the edges are not smooth as I have drawn here. So, there are rough edges of these plates. So, in layman terms, if they are converging, so the lithosphere, neither of one or second lithosphere is going to give way to the other. It is one will stick to its ground. It will ask to that move aside. I have to move, and similarly the second one. So they will stick to each other in the. So they will not allow. So they will sort of get interlocked temporarily. But what is happening? They are converging and they have locked, but the rest of the plate has not stopped moving. So rest of the plate is continuously moving. So a stress which is known as elastic strain, because it is a solid body, some way or the other they cannot be compressed like a gas. So some way or the other there will be a time when the two plates will say enough is enough. Okay, we I'm going to just sort of make war against you, and it lets go. So this strain, this flicking of the finger, you can say, so this releases the built up elastic strain in the form of energy, also known as seismic waves. Okay. So if we want to define an earthquake, normally a layman or even a geography student is very difficult. Okay, earthquake, they get confused. So in simple words, if I divide it into three parts, so it is a violent shaking or movement of the Earth's surface due to release of the built up energy in the Earth's crust, or normally we use the term lithosphere, and which is normally a result of the movement of tectonic plates. Lithospheric plates we have already understood. Lithospheric plates are also known as tectonic plates. No need to focus what is tectonic. Tectonic basically pertains to the forces which are acting, these convectional currents which are acting beneath the surface of the earth and which is providing the energy. So this is the tectonic. Now, so this is the earthquake. Now this, what I have drawn here, I'll just erase it for time being. Okay. All these symbols I have specifically intentionally posted so that it becomes easier for us to understand. Now this is an illustration of the Richter scale. So currently the magnitude of the Klitschevskoy, not the Klitschevskoy, the earthquake which occurred on the coastal area of the Kamchatka Peninsula, it was 8.8. So Richter scale, it determines the magnitude or the amplitude of a particular earthquake, and it is in logarithmic scale, which means that if there is an earthquake which is 7.8 magnitude of Richter scale, this means that 7.8 will be 10 times less potent, or will be 10 times less amplitude as compared to 8.8, because the Richter's the logarithmic scale is in the multiples of 10, or we can say an earthquake with a magnitude of 8.8 is 10 times as powerful as the earthquake of magnitude 7.8. So this is a quantitative measure. There is a qualitative measure also for measuring the intensity or the devastation, or in plain terms the amount of shaking, and that is measured by the Mercalli scale. Okay, so this is a qualitative, because a simple example is, for example, the structures in a city like Delhi, if we go to Chandni Chowk, Lakshmi Nagar and such areas, so the buildings, even in we go to Dharamshala and all, of late a lot of devastation has been caused by flash floods, and these structures are there, the hotels, the buildings, roads are not suited for handling this kind of catastrophe, this kind of vibration. So they will collapse easily. So if an earthquake of magnitude, say 6 on the Richter scale, occurs in Delhi, and the same magnitude earthquake occurs in Japan, so it is bound to cause more devastation in Delhi as compared to Japan. Why? Because there in Japan, not only are they used to it, they are building structures, they're building houses, infrastructure in consonance, in taking into consideration the harmful or the catastrophic effects that the earthquake can cause. Okay. Then, next, after earthquakes. This is the illustration for tsunami. What exactly is a tsunami now? That is why definition helps you remember for a long term. So tsunami is a Japanese term made up of two, su and nami. Su means harbor and nami means wave. So tsunami basically, if I again divide into keywords like I did while defining earthquake, so it is a series of massive waves which are generally formed due to underwater or undersea earthquakes, and which have the potential to cause large scale devastation in coastal areas. Okay, so the earthquake which took place off the coast of the Kamchatka Peninsula, it produced the tsunami to a height of as high as 13 feet. Okay, so this is capable of drowning major coastal cities. So what happens is, some of the conditions that are necessary for generating a tsunami. First of all, there should be a source of energy. Earthquake is the most common. The source of energy has to be there. Then it should be shallow focus. Two more terms associated with an earthquake. I'll just illustrate with the help of a simple diagram. So basically, if this is the lithosphere, or we can say in general the crust, so the earthquake is generated here. Okay, so this place at which an earthquake originates, it is known as the focus or hypocenter, and the perpendicular place, the place at which is perpendicular, shortest distance from the focus at which on the surface of the earth the earthquake is first determined or observed, it is known as the epicenter. So in the news you mainly come across this word, the epicenter. Now, shallow focus means if we consider this Earth and this is the lithosphere, so if the earthquake, the focus is deep, so the energy will spread in a wide area. So it will not be as devastating, or it will not be able to provide as much energy to generate high energy waves, sea waves, which can become catastrophic tsunamis. And on the other hand, if it is shallow focus, so the energy will be more concentrated, and further, if there is water over it, it can be vertically displaced. The vertical displacement of water is very important prerequisite for the formation of tsunamis. So, like I gave you a simple example of how the plates are moving. So, it is sort of a when they release the elastic strain, they sort of produce a flick like this. So, they produce a vertical displacement. Okay. And so, this is how a tsunami is produced. Then obviously a the earthquake can also leads to the volcanism or volcanic activity. How? So for volcanic activity, again prerequisite. First of all, there should be magma already there which is ready to erupt. Okay. Second, the earthquake releases a lot of energy, so that energy can further provide impetus, because magma, along with liquid magma, there are a lot of gases also which can be compressed by the energy and force this liquid to move out of the vent and make the volcano erupt. So it is like you can relate it with the shaking of a soda bottle. Like we shake a soda bottle, and finally when we open it, the pressure is released and it erupts. And also, an earthquake can produce more fissures, because what is required in the earth, the magma needs a way to come out. So if more fissures are produced, so it will find more ways, the magma can find more ways to erupt outside. Okay. So this is the basic what has happened. So tsunamis were generated, the tsunamis were the warnings, the effects of tsunamis were experienced as far as New Zealand. We are talking when I showed you the map, we are talking about the northern hemisphere. If I locate here, the not only the warnings of tsunami were issued in Japan, but also here till New Zealand. So you can see how powerful these tsunamis can become. Okay. Now next, the important thing is, why is this Kamchatka Peninsula is so prone to earthquakes? Okay, so quickly I'll draw a diagram to help you visualize. Okay, so I think you can recognize this. So this is the Pacific Ocean, this is the continent of Asia, this is Australia. Some countries I'll mention: Papua New Guinea, this is the Malay Peninsula. Here we have the Sino-Indian group of countries: Cambodia, Thailand, this is China, Taiwan, Japan, the Korean Peninsula, this is the Shandong Peninsula. This is the Sakhalin Island, part of Russia. These are Kuril Islands. Very important, we'll discuss it. So Kuril Islands are a disputed territory between Japan and Russia. This is the Kamchatka Peninsula. This is Alaska. This is North America. This is Mexico. Then the Central American countries. This is the Caribbean. This is South America. Okay. So this entirely is the Pacific Ocean. Now, this I'm going to talk about the Ring of Fire. Okay. So what exactly is a Ring of Fire? This is a Ring of Fire. This this is New Zealand. Okay, so how can we define a ring of fire? It is an approximately 42,500 kilometer expanse of length, okay, horseshoe shape, which traverses major plate boundaries, okay, and where 75% of volcanic eruptions take place. It is home to 450 active volcanoes, and it contributes 90% of the earthquakes taking place, massive earthquakes taking place all over the globe. And the countries where, and we have already discussed previously what is a plate, what is a tectonic plate. So this simply boundaries, these marks the boundary of various plates. So just pay attention. So basically, if we mark the different names, so this is a Pacific plate, basically lithosphere. It is a lithosphere which is a separate plate. Then here we have the Eurasian plate. Here we have the North American plate. Here we have the South American plate. Okay, here we have the Australian plate. Here we have the Indian plate. So all these boundaries, what we discussed is the tectonic. Why the earthquakes, why volcanicity is being reduced is because they are continuously slipping, sliding, colliding, producing faults between these boundaries. Okay, so here what is happening is this plate, the Pacific plate, is subducting under this plate. I'll just name the plates also. You might find it a bit challenging, but so these contains this boundary. Not only are they famous for the earthquakes, but also major active volcanoes of the world. What happens is basically you can see here. I talked about the converging plates. So what happens is when the plates are moving towards each other, so one plate may subduct beneath the other plate. Now, what happens after subduction? We know in the interior of the earth it is very hot, the temperature rises. So, as this one plate subducts beneath the other plate, so this plate start melting, magma is formed, and when sufficient pressure is created, when the magma finds a conduit or a way to reach the surface, it can erupt and form a volcano. Just a simple explanation for the time being. So we can also mark the major volcanoes which exist along this Pacific ring of fire. There's a type of ring, horseshoe shaped. It exists in the Pacific, along the Pacific fire, because it denotes the high intensity of volcanic eruptions. So some of the volcanoes which you might have heard, Mount Fuji, here we have already discussed Klechevskoy. Then here in the Alaska region also, it is prone to volcanism because of subduction ranges. This is known as Iliamna. Okay, here we have Mount Rainier, Mount St. Helens. Here we have in Mexico Paricutin. Then we have Popocatépetl. Then in Ecuador we have Cotopaxi. We have Ojos del Salado. We have Mount Aconcagua. Okay, then in New Zealand, we have Ruapehu. Okay, you can see that the the Australian country, or the this country does not have any significant active volcanoes because of the lack of subduction zones. Okay, then in Philippines we have Mount Mayon, Mount Taal, Mount Pinatubo. Okay, and recently a lot of volcanic eruptions were in news. So there was another in this by the name of this in Nicaragua, the Telica. Okay, in Colombia also there have been, so there's Central American countries. This Nicaragua, Costa Rica. Okay, so these countries are prone to earthquakes as well as volcanism. Some few or more, because these terms continuously keep on coming in the news, so you should be aware of this. You might have read this trench. So what is a trench? Trench is basically a narrow and long depression which is found at the subduction boundary. So you can see here, when the subduction is taking place, a deep depression is formed here, which is known as a trench. Okay, so here you might have read in the news, this is known as the Kuril Kamchatka Trench, because we have already discussed the places. Here we have the Japan Trench. Here you might have studied, because the plates, again, there are major plates as well as minor plates. So here also this divides it into this part. This is the Philippines plate, and here we have a very famous trench which you have been studying since time immemorial. That is the Mariana Trench, the world's deepest trench. Here we have the Karmadec Trench. Here we have the Tonga Trench. This is the Hebrides Trench, and this is the Karmadec Tonga Trench. You might have, a few years ago, the Tonga Island volcanic eruption took place, which was felt all over the world. So this is why this Kamchatka Peninsula, so we have discussed why it is prone to volcanism. So this is the basic stuff. And major earthquakes, if we discuss in the, so the highest magnitude earthquake took place in 1964 in Valdivia in Chile. It had the magnitude of 9.5 on the Richter scale, the highest magnitude earthquake recorded till now. So it led to a loss of around 1,600 lives. Then in 1960, another earthquake in Alaska region. Okay, so it was of the magnitude 9.2, around 130 dead. Okay, then in 2004, the Sumatran earthquake. Okay, so it was 9.1, and it led to deaths of around 3,70,000 people across 14 countries. The adverse effects were also felt on the eastern coast of southern India. 2011, the Tohoku region in Japan. It was around 8.5 magnitude. It led to 18,000 people missing or dead, and it led to that worldwide famous or notorious Fukushima nuclear disaster. Okay, so these are just some of the countries which you need to keep in mind while discussing. So, for example, we have this is the flag of Colombia in the southern America. So here there is a volcano which was in news recently, Urace. Okay. Then there was this Nicaragua, where we have already discussed this name, Telica. Okay. This is Costa Rica. Okay. So there is a volcano Poas, which was in news. This is Papua New Guinea. So there was a volcano is news, Bulusan, and this is Philippines. Here, Ulawan. Okay, so some things from the point of view of competitive examinations. One thing, there are apart from major plates, you might have also heard about this actually it's the Okhotsk Sea. Okay, so although the plates they go like this, so this plate, this is a minor plate. It is known as the Okhotsk plate. So in the news, it was there that this is subduction boundary due to which the earthquake took place near the Kamchatka Peninsula, and consequently volcanic eruptions took place in two important volcanoes. One was Klitschevskoy and the other was Kreshninikov. So this Okhotsk plate, Okhotsk Sea, this specific plate is subducting northwards at the rate of 86 mm per year. So by tectonic standards, this is very high. So this is a tectonically active zone. This is the Philippines plate. We have various plates here, the minor plates, the Juan de Fuca plate, the Cocos plate, the Nazca plate. Okay, so all this you should be aware of. Finally, one last concept which is also important. We have discussed about the subduction. One important concept is that of a fault. So fault in plain one liner definition, it is a rupture or fissure prominent between plate boundaries or in the crust or lithosphere, along which discernible or observable displacement takes place. Okay, so one common phenomena which now faults are of different types. One common fault which is associated in this specific ring of fire is the reverse fault. Okay, I'll just discuss in brief. Okay, so what exactly is a reverse fault? So we know there are gaps between the plates. Sometimes what happens is, to imagine there are, I think you can easily correlate or imagine the 3D. So these are two crustal blocks. This is the fault plane. The diagonal, the slightly tilted one, this is a fault. That is because movement is taking place. So how it can be explained? Now, initially, for clarity, I'll just draw this. So now it should be easier for you to analyze what is taking place. So, okay, so you can see the movement. This block has moved towards the north, or not towards the north, upwards as compared to this blocks. These two blocks were simultaneously, they were juxtaposed. So this layer was matching this layer, but due to the release of elastic strain or the release of energy, this block has moved upwards as compared to this. So this is known as the reverse fault, and this happens due to compressive forces. So this reverse fault, and it is also leading to the vertical motion. So again, if there is a sea located, water body located on top of this, so this will displace the water, vertical displacement will take place, and tsunami like waves will be created. Okay, so just this is actually the hanging wall, and this is known as the foot wall. Okay, a lot of concept. I'll just summarize. So we had started with the explanation. I hope I've tried my best. For those of you who are new to this topic, or those of you who are not well versed, who want to study, who have studied in their syllabus, so we had discussed, try to discuss in a systematic way of what is going on where and what exactly. This is very important. The earthquake, the occurrence of earthquakes has increased in the recent past, and we need to be, a lot of earthquakes will be in the news. So whoever, a layman who is reading a newspaper, so he will also come across a lot of these terms. So he will also be interested. He will also, if we go across this, whatever I have discussed today, if he or she goes across the newspaper, he or she can be easily relate to these concepts. So I hope today's discussion was enlightening for you. So till we meet again next time, Jai Hind.